With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, a time varying force acts on a particle of mass 5 kg as shown in the figure. Find speed of the particle in meter per second after 10 seconds if particle was initially at rest. So here, this is our particle. At t equal to 0, particle was at rest. We need to find its velocity at t equal to 10 seconds. So t equal to 0, speed is 0. We need to find its speed at t equal to, we can say as 10 seconds. So here we can see this body has mass of 5 kg and we can say here its speed at 10 seconds is suppose v, which we need to calculate from this graph. Now here the graph is between force and time, hence we can see here area under the curve and time axis will, let's say here, give us integration y dx means integration f dt, which here is equal to, as we know, force is equal to rate of change of momentum, that is dp by dt into dt, hence this comes here as dp, that is change in momentum. So here initial velocity is 0, that is we can say here initial momentum will also be 0. So here we can see limit from initial momentum to final momentum, hence this comes here as p with limits as, let's say pi2 we have here as pf, so this comes here as pf minus, we can say here as pi, hence this final momentum will be mv, initial momentum is 0, so mass of the body is 5 kg, so 5 into v is the corresponding area. Now we need to find the area which gives us here velocity. Now here we can see this, let's say the portion of the graph OA, B we can say as C is a trapezium. We can see here this CD, E is a triangular region, and E, F, G, H here is again a trapezium. So this area is suppose A1, this area is our A2, and this area here is our A3. So we can see here this area A1 can be written here as we know trapezium area is equal to half of sum of parallel sides. So we can say as our 2 plus 3 into height, which is equal to 10. So this comes here as, let's say 5 into 5, which is equal to 25. Similarly, area A3 here also can be written here as we can say here as half of sum of parallel sides, which is equal to, we have here as 2, and here this side we need to find EH length. EH length here can be found out by, if we draw a perpendicular from point D on the line CE, we can see here this, let's say here line drawn from point B onto the base here, we can see, let's say onto this base, we can say here this perpendicular line gives us these two triangles as our congruent triangles. We can say here this triangle and our this triangle both are congruent triangles, as here we can see this is our 90 degree, these two sides are each of length 10 meter, and these two angles are, let's say, vertically opposite. So these two triangles are congruent, hence these sides must be equal. So this is of 1, hence this must be of also 1, hence this is equal to 4. Similar way we can say this and this is also congruent. In similar way 90 90, let's say same length sides and vertically opposite, so these two triangles being congruent, hence this must be the midpoint. So midpoint means this here is equal to 6. So here we can see this, let's say area of trapezium EFGH here can be written as half of sum of parallel sides, which is FG, which is equal to 2, and here EH, which is equal to 4, into height, which is equal to 10. So here this comes as our 30, and area, let's say A2 of this triangle can be written here as our, we can say as half of base into height. Base here is our 3 and height here is our 10. So this comes as 15, hence the net area here can be written as A1 minus A2 plus A3, as A2 is in the fourth quadrant and A1, A3 are in the, let's say here, first quadrant. So A1 we have here as 25, A2 as 15, and A3 we have here as 30, which comes out to be our 5V. So this comes as our 10 plus 30 as 40 is equal to 5V. Hence the speed at 10 seconds is equal to, we have here as 8 meter per second. Hence we can see here 8 meter per second is our final answer, which is the speed of the particle at 10 seconds. So this is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.